Hello, Siddharth. Good evening.
Okay. Hello, sir. Is my voice
Yeah,
audible
now
now?
audible. Good evening, Siddharth.
Good evening, sir. Good evening, sir. Yeah. So, one second. I think. Yeah, I think the microphone is phone is also set up. Perfect. So, yeah. Good evening to everyone. So I hope yesterday you actually got a glimpse into what countercrafting is, and so today what are we going to see is we're going to see the steps which is necessary for us to uh, right from our CAD design, how to slice the data and how to send it to a 3D printer, and then basically how to make it print objects. So unfortunately, we don't have a countercrafting 3D printer with us because they are still in research stage, and around right now there are a dozen of companies who are working on in creating doing research and development in countercrafting technology with several 3D printers. But we could also give a shot actually. The basic fundamentals are all completely same. There is no difference. Okay, I think I'm losing my presentation. Let me just again regain it. Yeah. Okay. So the basic technology between the countercrafting 3D printer and a normal fuse deposition modeling 3D printer is kind of same. So without any further ado, let's just get into our presentation. And yeah. So today is day 2, and yesterday a quick recap. We actually had discussed about what countercrafting is and what are different 3D printing technologies which current. Okay, I think if at all, if unfortunately if you haven't unmuted, if you have unmuted the mic, so kindly ensure that everyone mutes so that we wouldn't have any disturbances. And yeah, so and even yesterday we actually had a lot of questions on several questions to be in fact on how compact a countercrafting 3D printer can. And to give a glimpse on that, I even told you about, like, we'll be posting the videos and the reference links to those questions in our Google Classroom. But unfortunately, due to some technical reasons, like maybe because not all of our participants are using Gmail ID, we were not able to post our videos. So kindly ensure that you have a Google email ID so that you could be enrolled into the Google Classroom. And once after we have enough participants, we could share our resources in our Google Classroom as well. And so now let's take a look into how exactly a countercrafting 3D printer works. Yesterday we saw animations, and today let's see how exactly a countercrafting 3D printer deposits concrete, and how the walls are built. And hopefully in today's session, even we even have a couple of 3D printers over here. If you could just quickly change the view in your Google Meet to my camera feed, you could actually see like I will show you how 3D printers work today. let's try to build a miniature version of a wall uh, using using let's design a wall, slice it using different settings, and let's see how slicing works. And if possible, if time permits today, let's try to 3D print. If not, tomorrow I could show you in detail how the 3D printing also works. So without any further ado, I'll just show you how countercrafting 3D printer works before. Yeah, now you could actually change your view to the presentation view so that you could see the video. So these are all research-based, countercrafting 3D printers. Basically, the extruder versions. This is a very miniature version of a countercrafting machine, which replicates how the concrete is deposited. So these are all some tiny objects which are being printed, and the actual scale of machines, the countercrafting machines needs to deposit a very high flow rate of concrete, right? So only then it would be feasible for us to develop or print huge buildings. So as you can see over here, this particular machine is actually depositing material for building the walls. Notice how the walls are printed. They are actually hollow wall structures and not complete solid. And as you could see over here, there are a couple of extruders on extreme ends. So we call this particular feature as the external wall. Okay, so this is where this particular portion is what normally human can actually see once a building is printed, and they can't see the infill. So infill is actually the portion which is between these two layers. So as these two couple of extruders are depositing material on either sides, once that process is over, there is another separate extruder which is used to deposit the material in between these two layers. And it is not like only okay. This is not the only way of developing or building a wall. There are several techniques. This particular printer actually uses this type of printing method, whereas in some other printers, the same extruder will be used to print both infill and the external part of the wall as well. So this is next to the okay. And as you all know, it doesn't mean the walls to be in a typical typical straight line or very constrained geometry. But with countercrafting, you have the flexibility to make it go whichever way you want. So it could be a curved structure, it could be a arch structure. You could also make these walls not even perpendicular. You could make them even curved structures as well. And even in yesterday, there was another question like how compact a 3D printer can become. So to answer that question, I have another video here. So this particular company actually develops a 3D printer, which is actually up for sale and hopefully in this particular year. So that's what they have promised. I could also show you them, show you the works which they are doing currently. So as you can see over here, this entire house is built using a single 3D printer, and the 3D printer actually resides inside the portion. Normally a 3D printer requires a gantry crane kind of mechanism for them to move on rails and stuff, which is actually which will consume a lot of space. And for countries like India, whose cities are super crammed and space is super luxury, printers like these could actually help us to build more affordable housing. In terms of affordability, if you wanna talk, so this particular building which you see over here actually costs around $10,000, which is not a lot. I could also, if possible, let's quickly check out this particular company's website, which is actually interesting. So, to my knowledge, this is the only company who, as of now, who have promised to sell their 3D printers. Um, yeah, to sell their 3D printers in the market in real soon. Or else what we can do is we could actually, like, I think we have a very limited amount of time, so probably what we could do is we could I'll just share the link of that particular company in our Google Classroom so that you could just discover it later on. Yeah, so now let's quickly get back, because today we have a very jam-packed session, so we need to discuss the printing workflow. So yeah, so coming back to our topic, so as we discussed yesterday, we have three different steps for 3D printing process. The first step begins with the design part. All right. So the design part can be of, it could be any software. You could use let it be any CAD modeling software, let it be any mechanical. As a matter of fact, you could use mechanical softwares like, say, CAD AI Pro E, Fusion 360, like any software which could actually, draw a 3D model. And especially for contour crafting and especially for civil students, you have softwares like, right from basic softwares like SketchUp, all the way to, say, Rivet and AutoCAD 3D, Rhino. There are tons of software. Like, you could choose any software for the design part, but always you got to follow certain guidelines, which you will be knowing once once we see the slicing part, because the slicing part is the most important part that will decide whether your design is printable or not. And you should be knowing what is the, you should match it with your printer's capability as well. There are certain challenges, okay, but if I tell you those challenges right now, I think it would be difficult for you to grasp those ideas or concepts which I'm about to tell. So instead of that, let's actually take a look into slicing, which is actually the step 2 of the entire 3D printing process. So in slicing, what we do is, as I told you before, slicing is a process of, creating entire the G codes or the instruction set for 3D printer. All right. So slicing is actually the intermediate step, and because since your 3D printer or your photographic 3D printing machine is, it is actually dumb machine, so it can't understand. If you give it a 3D model of your building which you designed in a Rhino software or a AutoCAD 3D, it is complete gibberish for that printer. So for that purpose, what we need to do is we need to slice them, convert them into G codes and M codes, which is the same technology which is being followed by CAD/CAM machines as well. So if you see a CNC machine, they, like, if you ask your mechanical students counterpart, the routers, they work on the basis of, following G code commands. So this particular slicing software actually creates a G code command. Now let's quickly get back to a software where so for this purpose, what I'll do is I'll actually use a Fusion 360 to design. Okay, I'll just quickly use a Fusion 360 software to design. Once again. Okay, I think I need to restart. Okay, by the way, Fusion 360 is actually a software which is used to create mechanical models. So just for our understanding purpose, we are planning to build a wall section of a building, probably like, say, a corner portion of a building, let's just try to explain you with that particular wall. Let me try to explain you what is slicing and how to do slicing, and with the right amount of objectives, and so that you get a better idea of knowing the limitations and using the designing software to its maximum potential. Okay, I think it just needs some time. Shouldn't take a long. Yeah, cool. So we are back. So now what I'll do is I'll just create a basic floor section. Probably normally in our building construction it actually goes in normally we used to use feet and inches, but since we are using a 3D printer which is having a build volume of say very small, to be as a matter of fact, the machine which we use right now is actually it is having a build volume of, if you could just turn on the just again switch back to the camera mode, if you can see me right now. So this particular machine actually has a build volume of 140 mm by 140 mm by 140 mm, which is actually okay. Let me just turn back the camera so that you could see it, see the machine properly. I do hope that you have actually changed the view to the camera. And once after some time, let's get back to the presentation part. So this particular area which you see over here, where the extruder can move, is actually called as the build volume. All right, and so the parts typically print on this particular platform. So this particular platform is of a size of 140 mm by 140 mm by 140 mm. So that is with this particular printer. And with this particular printer, it is actually a bit larger. Let me turn around the camera. So this printer can actually print in a volume of 230 mm. So again, it's all in mm. So that's the reason why we won't be able to print huge structures using these machines. But if you want to print a huge structure, all you need to do is beef up these printers, scale it up, build a printer such that it could move for several feet and could deposit cement as well. So in that way, we could develop a counter crafting machine. All right, so you could just again turn back to your presentation view so that I could continue with my software part for designing and 3D printing. Okay, I do hope you have once again came back to the software. I mean the presentation view. Okay, so if you see now, so we are planning to build a corner of a room. So for that purpose, I'm using a dimension of 50 by 50 mm. All right. So, and I'm just quickly giving it a height of say 2 mm, just for our purpose of understanding. So let's just assume this is the floor. And now what are we going to plan is let's just build some few basic wall structures over here. Let's give a thickness of say 50 mm. All right, so I mean, let me just give a thickness of say 5 mm by 5 mm. Yeah, so I'm just subtracting the distance so that I have the remaining portion for my wall. Now what I'm going to do is I'm going to increase my wall distance to say another 40 mm height. Yeah, so now we have a very basic corner portion of a building. All right, so normally for so normally once your design is completed, you should also basically during the design phase, I have actually simplified the design phase in a very subtle way. But a normal design of of buildings of if you want to build a building using contour crafting, during the design phase you should have a lot of emphasis on, say, load bearing capacity, like where to place those inserts of rebars and other stuffs. So those are all still there, but it's actually way out of our subject for us right now to discuss about those stuffs. So so quickly, let's just get back to our next part of our process. So now that we have designed a very basic version of a wall, a corner portion of wall, let's just get back to the slicing portion, which is the most again important portion for converting your designs to a G code file. So for that purpose, we are again getting back to this Fusion 360 software. And I'm just going to use an option called 3D print over here. And there is an application called Cura, which we are planning to use for slicing purpose. And if you ask me if can we use the same particular software for a counter crafting 3D printer? Of course, you could. Technically, you could actually use it. Since the base, the fundamentals of 3D printing with FDM machine and the counter crafting machine are almost similar. You could actually use this software, but you need to modify certain parameters over here. Okay, parameters such as build volume, parameters such as the extruders. Yeah. So yeah, parameters such as the extruders capability and a lot of the stuffs. So since Cura is an open source software and it is free to download, you could actually use it to use the same software to deposit concrete as well. So let me just quickly orbit this particular section so that we have our intended floor and intended wall in the current orientation. So as you could see, the orientation is fixed. So for that purpose, I have just used basic tools. So there are certain tools like transform tool, scale tool, rotate. Scale is used to increase or decrease its size, and rotate is used for orientation purpose. Mirror, per model slicing. Okay, so these are all some advanced options which we are not going to get into right now. And I would also suggest you and recommend you to download this particular software. It is open source and it is free to use as well, free to download and free to use as well. And we will also leave a link to this software's URL in our Google Classroom. So now that we have placed our designed section of wall, let's take a look into our slicing settings. So now we are actually so there are three different views over here. You could see prepare, preview, and monitor. So prepare is the area where we will prepare this particular model to 3D print. All right. So for 3D printing purpose, so let's just get into the profile part. So there are different profiles. Okay, so basically, if you choose any of these profiles, it will actually vary the difference in parameters. But all you need to know right now is, the most important part is knowing the parameters of the slicing software. All right, so basically, we need to set the layer height. You should tell the printer what is the individual layer thickness. So individual layer thickness is actually the thickness which you could see over here, the thickness of one single layer. All right, so how much thickness your extruder is going to extrude and on a single layer, so that actually depends upon your nozzle diameter and the flow rate of your mixing chamber. It depends upon various parameters which you need to calculate and develop. So but since in our 3D printer, since we are actually using plastics, and these printers are designed and optimized for printing in a very thin layer resolution, because normally what happens is your your layer resolution actually depends, dictates the quality of your 3D printer. I could give you a good example what layer resolution is over here. So you could see, the three different images at the bottom actually represents, Apple, but the one image which is actually closely representing to Apple is actually the third image. The reason, because when we have more number of layers, more quality you will be getting. Okay, so when you increase the layer thickness, you should sacrifice on the quality part. It is something similar to your screen resolution. Like, say, the devices which you are viewing right now has a dots per inch. So we normally call it DPI, or the pixel resolution. So more pixel resolution, more quality will be the content which you are viewing, right? So similar to that, more number of layer resolution, or you have more quality as in aesthetically speaking, not as in structurally speaking. Okay, aesthetically, the part will look much precise, especially when you are trying to build arches or any curved structures which are not rectilinear. So in those areas, when you have more number of layers, you will have more precise output. If not, you could actually finish with a lower resolution. Especially in contour crafting, the layer resolution normally ranges somewhere around, like, say, 50 mm. It's about 5 centimeter. uh, and because we need to build, mostly the walls are actually perpendicular in contour crafting case, right? So for that reason, the layer resolution is uh, bit low, as in the thickness of the layers will be a bit higher. And for during only for the curved sections alone, what people will do is they'll be applying plaster anyhow. So normally the 3D printed buildings, if you see, actually have layers visible. So you could see over here the visibility of layers. See, you could see the multi layers over here. These lines actually represents the layers for yeah, and even in this particular area. So normally what happens is, once after the this particular house is completed, for getting this particular effect, you got to obviously plaster it, and paint it later on, which is again a post processing technique. Okay, so for that purpose, you know so this is the primary reason why we need to consider layer height or layer resolution. And the second most part is actually, now let me just go to the preview view so that I could share you how the entire process works. So in our case, we have a nozzle, and I have configured this particular mission uh, with a nozzle diameter of 0.4 mm, which, if you want, I could actually show it over here. All right. So our particular machine actually has a nozzle diameter of 0.4 mm, whereas a counter crafting 3D printer could have a nozzle diameter of several uh, inches, probably couple of inches, because more number of the more the nozzle diameter, or say more the nozzle cross sectional area, the more amount of material can be deposited. All right. So, but in our case, we have a 0.4 mm nozzle diameter. So with 0.4 mm and with 0.2 mm of layer height, we are depositing plastic in this particular way. So it actually builds the entire outer wall, and then it actually lays the material for the flooring part. I guess you could recall our yesterday's video, which actually which shows an animation how a counter crafting 3D printer deposits material. Initially, it would actually deposit uh, once the foundations are prepared, the material will be deposited on the floor or on the top of the foundation, which should be very much flat. And once so this is how. Okay, now since the first layer is completed, this is actually the animation of the second layer. So it actually, you could see how the pattern changes. So all these settings can be configured over here in this particular slicing software. So that is the purpose of developing slicing software. And the part which you see over here is actually the extruder of the machine. So basically every different line actually would be translated to a G code in the Cartesian coordinate system. So this particular software will generate the instruction set, which will be sent to the 3D printer, which will have all these informations. Say at what point how much amount of material it should deposit, and from that point, what is the next point it needs to go, and at what speed it should go, and at the same time, several parameters like say what should be the mixing chambers ratio of mixing part A with part B. But if in our normal 3D printing case, you have different other parameters like say how the cooling fans should react, at what power it should work, and different stuffs. All right. So now we have seen the significance of layer resolution. So what you saw right now is actually a quick animation of 3 different layers being printed, and the fourth one is currently being printed. So I hope you can also see the number of layers over here, or if not, let me just let me quickly show you the building process. So you could see the different layers, right? So this particular thickness of the layer is actually called as layer resolution. Okay, all right. So now let's come to the shell part. Shell is something which is again very important in Okay. So if someone unfortunately you haven't if you have unmuted your device, kindly ensure that you stay in mute so that we don't have any interference. Let's have our discussion session later on at the end of this particular session. So the wall thickness is actually the thickness of this particular. Now that, okay, don't confuse yourself with the what exactly wall represents over here. So according to our design, this particular whole area is actually wall of our building, right? But the wall which is representing over here is not the entire wall, but rather the wall of this particular part. So you could see the 3 different lines over here, right? So these 3 different lines actually constitutes a wall portion. So let's say if we don't want 3 different lines, let's just go with a single line. In that case, what happens is, let me just quickly update this particular value. So now you could see the outermost shell is being printed with infill inside. So this particular infill is actually kind of a cubic infill. So again, to give back a reference, let me quickly show you the video which I showed you before, where this particular effect is clearly visible. So currently right now, if you see, so this particular portion is actually printing of the external shell, and this particular portion is printing of the infill. Okay, so now going back to our slicing software. So this is where the shell parameters are important. So let me tell you what is the difference between going with a single shell or a multi-shell thing. So normally a single shell actually gives you uses much less material, but going with a higher shell actually increases the material consumption, and at the same time also increases the amount of insulation and sometimes even it also increases the structural rigidity as well. But it totally depends upon your nozzle cross sectional area, the cross sectional area of your countercrafting 3D printer's nozzle. So how much amount of material it is going to deposit, right? So that implies a lot. I mean, that actually uh, that that is the most important parameter. So let's say if you have a length of say 50 length and say 20 width of a nozzle. In that case, if you want to have a shell thickness of say 10 you need to go with two different uh, you know the shell count should be like 2, so that you will have 10 of uh, the shell distance achieved using a 5 nozzle. So but rather, if you want to have like say only 5 shell, or if not, if let's say if you want to have a 10 shell with but you're having a nozzle which could extrude at 10 then you could go with a single shell itself, because both are creating the same result, right? So that is why you need to tweak these numbers into your software. All right. Again, okay, the top and bottom thickness, top layers. So these are all parameters, which is actually used to fine tune the entire printing process, which is especially while printing the bottommost part or the topmost part. Let's not get into those parameters right now. Okay, now let's just quickly skip to infill part. Infill is the part which you see over here, which is inside these two different shells. All right. So the percentage, which is currently it is at 20%, represents the density of the infill which is going to deposited by the extruder. What would happen if I increase it? Let's say if I increase it to 30%, and let me just quickly slice it. So if you could notice, the density has increased over here. Let me to make it much more visible, let me make it to say 80%. It is not ideally recommended. Not like it again depends. So when you go to 80%, you could see the amount of infill. It is almost solid. Okay, so you could go all the way up to 100%. Once you go to 100%, it is going to be a complete solid structure. So now let's just get back to 20%, or rather say 40%, so that yeah. And you could also control the parameters, how the infill type should be. All right. So the infill type can be, cubic, as in this case. So probably I'll just go to a different layer so that you get a exact idea of how. So this particular infill which you see over here is actually called as cubic infill. So there are several different infill options. The one which you saw over here in the presentation is actually called a slime. All right, so it is used to connect these two outer shells efficiently. So yeah, we have different options. So once every different option has its own unique advantages and disadvantages as well. Okay. So this particular option, which is called as lines, actually it is used to. Okay, kindly ensure that you have unmuted, because we are having some interference. Yeah, thank you. So there are different options like say lines, triangles. Let me just quickly skim to the skim up through them, so that we could get an idea of what these things are. So this is called as triangle infill, and you have a trihexagon infill, cubic infill, octet, quarter cubic, concentric, zigzag, cross 3D, gyroid. Gyroid is again another very efficient way of 3D printing, and even for counter crafting as well. When you have a very high thicker layer of materials, I mean, then you want to 3D print a very thick portion of a building. So you could actually use this particular thyroid infill type. So for our particular purpose, let's say let's 3D print using triangle infill. So apart from this, even there are even certain other infill structures also. We could print. We could actually choose a hexagonal infill and other infill as well. So now let's quickly get back to our presentation. Okay, yeah, I will also show you the process. The slicing is not yet over, so there are different other various process which you need to understand. But considering the duration, the objective of our workshop, it is just to give you a glimpse or rather an idea into what slicing or what crafting is. So we won't be able to go into much details into the slicing part. And yeah, so moreover, we are actually into the very basic version of slicing. So we are actually not touching out different other complicated, advanced options or features. So apart from this infill and wall thickness, all you need to know is at what speed you should be printing. All right. So even for speed, we could customize the speed uh, to a very different multiple options as well. So let me just give you a glimpse on what a spurt option looks like. Okay, I think. So it's going to take a while for the software, for the software to move. It so you have different parameters. So for customizing. So uh, I would highly recommend you to try out the software. This is pretty interesting and very useful software as well. All you can do is and at the same time it is also very user friendly. So once you install the software, so I will hopefully post this link of the software in Google Classroom tonight. So kindly give it a try. And at the end of our webinar as well, on probably on Saturday, you will be having a question and probably you'll be given a question answer session as well. Uh, uh, a mini test will be presented to you, so probably you could prepare for that. And learning the software is it is an added advantage for you to take up your final year project. Like say if you are interested to build a 3D printer which could 3D print buildings for your final year project, this would be a gold mine. So yeah, so probably you could just skim through all these options, and once you place your mouse pointer on top of any parameter, the software will automatically let you know what exactly it means. I think my layer my screen resolution is so high that I think it might not be visible for you. Let me quickly change it. So it would actually give you all these informations. Once you place your cursor on top of it, uh, basically it will let you know what exactly it does, and what are all the effects, and how that particular feature has been even affected as well. So let me again quickly go back to the previous version, or if not, let me just go to a normal standard. Yeah, I think this should be fine. So apart from this, you also have the material. Okay, don't consider. Okay, I think someone of you actually have turned on the mic. So kindly check you have been unmuted. Yeah, thanks for that. So apart from that, you even have like say different material options. But this particular machine is actually an FDM based 3D printer. We won't be able to so and the software is actually designed for 3D printing in for printers which could 3D print plastic materials. So that's the reason why you have printing temperature and other parameters. So all the values which you see over here is actually meant for like say the build plate temperature or the extruder temperature. Everything is meant for melting the plastics and depositing it onto the platform. But a counter crafting 3D printer doesn't require these parameters. All it requires is a mixing ratio, and at what rate the material should flow, and at what guys, kindly ensure that you have the device on mute so that you don't cause any interferences. And yeah, so once after we customize and set all these settings over here, so you even have options to say support is again to ensure that uh, let me give you a very quick glimpse into what supports are. Okay, so if you see over here in the image one, if you want to print a structure, something like say a T structure, you could print all the way up to uh, the this particular portion. Whereas if you want to print a structure with a 90-degree overhang, it is not possible for the concrete to instantly settle down, like say instantly cure and turn to solid, right? So for that reason, you need to have supports as well. So what normally happens is for structures like normally in buildings, uh, we would face difficulty while printing roof structures. So that's the reason why we in yesterday's video, if you could recall, we were actually like placing out uh, different support structures which could bear the entire roof portion. Uh, but even there are other several techniques in which without using support structures also people are doing some research to print out materials which could self withstand its own weight and then cure and so even researchers are they are being conducted and they have even certain companies have successfully demonstrated the technology. But all you need to know is right now for creating structure for this particular T, you need to have support structure. And for structure something like Y, which you see over here, it doesn't require a support structure because the overhang angle is actually not it is not 90 degrees. It is more. Guys, kindly ensure that you have muted yourself. Okay, so for structures like Y, you don't require support. So even for support options, you have uh, different options. Different parameters to control. And with regards to material, so I think I would recommend you to try out this software. So probably you could just have a glimpse and you could know what different options are. So these are all the various options to control the speed of the counter crafting, or if not say a 3D printer. So what should be the print speed, what should like how much what should be the extruder speed when it is printing infill. You could customize different things. What should be the speed of extruder when it is printing wall, and you could be very specific of say what should the outer wall speed or inner wall speed while it's printing. While basically while printing different section of the building. And you have travel, cooling. Cooling is actually the amount of time which you give, which you specify in the software, so that the extruder gives enough curing time for the concrete to cure. So as I told you, even support has different options, which is out of our particular scope right now. So once we are all done with this part, so we could you'll also have an estimation what will be the time and what will be the weight. But the time and weight which you see over here are for the parameters which are set by our machine. So normally these plastics ones, as I told you before, the extruders, uh, extruders diameter or the flow rate is very low, because it is designed on and optimized to print in a very low layer resolution. So that's the reason it is taking a lot of time. Whereas now in contour crafting 3D printers, the extruders cross sectional area is pretty high. So normally, if you want to print, a building of say in a magnitude of over 2,000 square feet, you could actually print it within less than a day time. Okay, so let me just quickly save this file, and let me just open this file with a WordPad, so that you could see how this G code actually is. So this particular G code actually runs to several say thousands of lines, if not even a few lakhs of lines of code. Okay, so all you could see over here is, so we'll be getting into the details of G code in the upcoming class, preferably on Thursday's class. So once you have prepared this G code, you could actually send it to a 3D printer, and then it will start 3D printing. So you could actually turn back uh, the view of to stop this presentation, and you can just click on my camera view so that I could show you how the printer actually works. All right. So I have actually copied the same file which we sliced in a pen drive, and normally these 3D printers come with different transfer options. So as we discussed yesterday, if you see, these machines can actually work on x-axis, y-axis, and z-axis. So now I'm actually moving the y-axis. So this is the x-axis of the machine. So this is the extruder part. All right. So this is the raw material which is actually the feed over here, and this build plate will actually move in z-axis. I hope you could see the z-axis part as well. Yeah. Okay. So since we are actually about to enter the end of our session right now, what I'll be doing is, let me just start the printing process, and but anyhow it won't be getting over today. So as you could see, it takes a considerable amount of time, but you could just see the process of starting up today, and let's just continue with the same uh, portion of printing in tomorrow's session as well. So now that the extruder is getting heated up to melt the plastic, it moves to its position. And once after this machine gets heated up, what happens is it will start depositing the material onto the platform. And tomorrow I'll also show you how to operate a normal plastic 3D printer, normal FDM, fused deposition model 3D printer. And hopefully, and from then on, our objective is actually to build a 3D printer, something similar to this line. This is actually an open source 3D printer. Okay, so even the same, it's pretty easy for us to 3D print a part. So if you could see over here, the printing process has been initiated. All right. I'll just try to give you a very a better look into what's happening. So let me also turn on some lights. So you could see the extruder depositing the material. So this is exactly same to the tool path which we saw in our simulation before. All right. So let me give you the detailed version of 3D printing. I'll explain you this particular process in detail tomorrow in tomorrow's session. So I think let me resume. So let me just give you a quick recap on what we have done. Let me just give you a quick recap on what we have. So we actually discussed about the slicing part, which actually deals with the supports generation and draft generation. So we saw how infill affects the print, and we saw what shells are. So these are all the three basic different parameters which we saw today. And apart from this, there are several advanced parameters which you guys need to know. So for that purpose, you could actually try out the software, and later on you could actually post questions, or if you're interested, you could post questions in our Google Classroom, and that will be answered as well regarding the slicing as well. So we saw what layer resolution was. So I think we are at the end of this particular session. So you could start accepting a few questions right now, and probably probably you could just start posting questions, and I think Mr. Dinesh could read me the answers. Yeah. Over to you.
Yeah, Siddharth. Siddharth, you're hearing, right?
Yeah, I'm perfectly hearing. Yes.
Yeah, okay. And actually, there will be some of the participants are posted the question.
Sure.
First one, Sandeep Gowda asked the question that reinforcement is required for slab or not in 3D printer.
Yes, Sandeep Gowda, I think you are actually talking about contour crafting 3D printers, right? So obviously, it depends. All right, so it depends upon the way in which you want to print. I will give you some. I will actually post an animation video in our Google Classroom today, which actually shows how a slab is being 3D printed without supports nor reinforcements as well. So in normal conventional method of building, you need to have reinforcements in your slabs because they need to bear the load. Just a simple concrete structure won't be able to efficiently bear the load, right? But there are certain companies who are in research right now, where slabs are created without reinforcements. So I think I have answered you, Sandeep Gowda. So I'll also share a link to that particular question today. Yeah. Yes, sir.
And Sandeep Gowda continuing that what are the softwares are there and which one are using right now?
Sandeep Goda, if you could just type in your question specifically, like say if you are focusing about say design software or a slicing software, I think you should have asked about slicing part only. If not, correct me in the comment section. Um, okay, so if it's going to be a slicing software, Cura is one particular software. The software which you see over here is one particular software. There are several different other softwares as well. Uh, you know, but not all of them are open source or free to download to use. Like say there are, I could show you some softwares like ZSuit is again another proprietary software which you use in some of our 3D printers. And there are even other slicing softwares like Slicer 3D. But in order to use uh, softwares like these, you should have a license, and that's the reason why I haven't showed you the slicing part. But there are several different softwares, Sandeep Gowda, for slicing. Yes, sir. Back to you, sir.
And actually, I think he's giving for some clarity that design and slicing like that words. Actually, Sandeep Gowda, that my suggestion, if you post your questions that what else in the Google Classroom, I think it is very clear that Siddharth can answer your question very clearly, and it is easy to everyone to get the answers also. And another one, actually, while in between that you are talk about projects, right? That while you just continuing the session, in middle you are talk about the project. Actually,
Yes.
one of the participant, I don't know, a student or a faculty named Gogan Nathan.
Yeah.
He is asking about some of the example of that final year projects. What may can from this 3D printing.
Yeah, Mr. Goganathan. So if you some examples of projects for your final year project dealing with counter crafting. So I would actually suggest you some examples. So the whole idea of having this particular series of workshop, 5 day series of workshop, is actually to give you an idea on how to build your own 3D printer, which could actually print the material. So uh, you know probably at the end, in coming session, what we will be discussing is we'll be learning into what G codes and M codes are, and then on one whole session will be allocated for learning how to build your own 3D printer, which I'll share you some certain links to certain sites, which has huge amount of resources on giving you knowledge. It's actually gold mine knowledge on choosing how to choose the electronics part, how to choose the motors, how to choose your embedded coding part, the firmware of the machines, how to make it respond and everything. So I think with that knowledge, you could actually make a lot of wonders. You could build your own 3D printer, which could not just print plastics, but even print deposit material of concrete and polymers as well. So to be very specific, I don't want to give you a limit your imagination with just a 3D printer alone. So with that particular knowledge, you could actually choose your own process, which could be very uh, technologically at a greater scale. So I don't want to make your ideas into turn them into a limitation part. So probably in the coming sections you will be getting a good idea. Yes, sir. Back to you, sir.
Yes, Siddharth. Actually, in middle, your voice is somewhat breaking.
Oh, okay.
Can you hear me actually now?
Yeah, I can hear you perfectly. Yes.
Okay. And another one question from a participant named Kadirwell, that he is asking about for slicing purpose, is there any other software except Cura? And can we directly upload the design from Fusion 360 to Cura to generate G code?
Yeah, that's definitely possible. So as you could see over here, even Fusion 360 also has a CAM option, so you could actually generate a G code file over here, but that is not normally we don't follow that particular process. So normally what we do is we will send this particular file to Cura, which is routed over here, and once the transformation happens, we will start editing the file in Cura, and then as you know, like even Fusion 360 also has an inbuilt slicing software. Okay, it even has a CAM option as well, but no, we are not. So probably if you could see over here, if you go to manufacturer option, you could actually configure a 3D printer into Fusion 360 and then start designing in Fusion, slice in Fusion, and then stream it to a 3D printer. So that option is still it is there in Fusion actually, but it is limited to certain parameters only. Not all parameters are possible. So yeah, so I think I have answered the question. So back to you, Dinesh.
Yeah, actually, the last thing is about economic thing. Two of the participants are asked the same thing. That one is about a 3D printer cost, sir,
Yeah.
and another one participant is asking about it is economic. The relatedly same. Both the questions are same.
Okay. So I think both of them are meaning towards considering their final year project. I think they would have asked a question. But I'll answer this particular question in two parts. So normally, if you see a counter crafting machine, a printer which could print a whole building requires a very huge build volume. So normally, when the build volume increases in a 3D printer, the cost of the machine also increase. So as of now, only dozen amount of companies are into 3D printing of buildings. So aka counter crafting. So those printers are in the market right now. Actually, runs to several crores actually. So but since the amount of research and development they have gone into it, and that will only come down when years pass on, not right now. But if you ask this question for your project purpose, I could give you the references of these two 3D printers over here. See, there are 3D printers which could print in plastics right from say around 15 to 20,000 rupees all the way up to a few crores of rupees. Machines which you see over here, this one costs around 40K in the market right now, 40,000 rupees, and this particular machine costs around like 25,000. And in order to buy parts, specific parts like the motherboard, like the stepper motors, the stepper driver ICs, SMPS, the mechanism, the rails, gantry, uh, the gears of the extruder, and like say very specifically the entire build parts of a 3D printer. Uh, it could You could technically build your own 3D printer under 20,000 rupees. All right, so even that's also possible. Um, to begin with, so in the coming session, I will also teach you how to build your own 3D printer. That is basically a glimpse on how to build. So we will discuss about electronics. We will also touch in and around coding part, G code, M code part, the firmware part of this machine. And if you're interested, if you're too much interested into Arduino and Raspberry Pi, so as a matter of fact, all these 3D printers works on Arduino Mega 2560 platform. So it's a very easy developmental platform. So in that way, you could actually use it for your project purpose as well. Yeah, back to you, Dinesh.
Yeah, see that, and actually, some questions are there posted continuously. Actually, I'll complete by last question. That actually there will be two questions. It's about the same nature. Karthik Verma, he is asking about plastering is needed for walls. This is one question, and another one question is also as same regarding the strength. The 3D printer walls that building or your object that printed using 3D printer, whether it could be as same as like normal walls or it will differ in the strength. Yeah, because both are like a same question.
Okay. So to answer Karthik Verma, see, plastering is not, aesthetically speaking, aesthetics are also very important, right? So normally a 3D printed house will have visible layers. Okay. So it will have a visible layer line. So in order to cover the visible layers, plastering is definitely required. All right. So normally what happens is once the building is 3D printed using countercrafting, plastering is, so that's again another post processing thing which we need to do. So, and to answer the second question, with regards to the strength of the wall, uh, so the wall strength is actually, if you compare it with conventional walls, uh, the composite material which is used over here is actually, much. It has a very high load bearing. Uh, you know, the load bearing of the material used over here is a bit high. So definitely, it is rated for a better uh, of of a normal concrete one. So, and moreover, I can't give you a very specific answer to this. The reason is because crafting is still in research and development phase. All right, so there are several materials which are currently being researched and developed. So when you normally use it totally depends upon the material. To be very specific, it 100% depends upon the material which you're planning to use. So based on that, so it could actually technically it could overpower the strength to weight, the load bearing parameter of a conventional one. Definitely yes. So back to you, Dinesh sir.
Actually, again, some more questions they'll be continuously posting. Again, about a wall size of the wall that could be constructed using 3D printer.
Okay. So the wall size is completely depends upon your design requirements. So if you want to design a wall, if you want to print a wall, like say a 10 feet wide wall, so even that is also possible. So as you could see, the walls are not complete solid. Okay, they can be made hollow. So uh, so all you need is just the build volume. If you want your wall to be fit for a nuclear bunker kind of thing, say a huge thick solid wall, even a solid wall can also be printed using countercrafting. If not, walls with hollow structures can be printed. So there is no limitation to the size of the wall. Yeah.
And the last questions is that we'll close by that. And the remaining questions, if a participants you have any questions, you can free to approach in Google Classroom. That is answered by a speaker. And the last question is about whether the CAD file or architect's for CAD or any Revit architect file, it can imported directly to Cura software.
Yeah, that's a very good question because thanks for reminding that question. The reason is because right now in Fusion, what I did is I have actually directly exported the file using an option called 3D print. All right, but in our Revit, in our Revit or let's say Rhino or other softwares, so it's going to be you got to export the file uh, in a different format. So there are different formats. Like say STL is one format. STL stands for stereo, uh, okay. So STL actually stands for stereolithography. Okay, and this particular file type is actually it actually just has the polygon data, and there are even other several options like say .emf format or .obj format. Uh, Once you export this particular file, let's say once we export the file, okay, so this is body1.stl. Yeah. So STL again, yeah, it's for serial lithography, and this serial lithography means a different thing, and not the SLA one which we discussed yesterday. And once you have exported an STL file, all you need to do is drag and drop the file into the software, and it gets imported directly over here. So that's how you will you could I think there are certain extensions available for AutoCAD 3D and Google SketchUp as well. And for with regards to Revit, I'm not sure, but I think you could actually explore this stage. If not, there could be some extension. So I think the remaining questions can be posted in our classroom. So I'll be happy to answer back to them by mid
Hello.
tomorrow. Yes, sir. Back to you, sir.
Yeah, actually, just now your voice is break. That what I interpret. Okay, we'll complete the session.
Sure.
And I to the participants, actually I posted today's feedback and link also, and also I posted yesterday's, that is day one, YouTube streaming link also there. If anyone wants to recap, or you can make use of that link, that YouTube link, that is yesterday's one. And also I shared a Google Classroom link with a Google Classroom code. Participants, anyone need of interact with a speaker, or you need about any materials or any doubts, you can come up with a Google Classroom and you can clarify your doubts. So thank you for all the participants for take part in this day 2 session, and thank you, Siddharth.
Yeah, thanks a lot to you as well, sir, for hosting the event, and once again, thank you everyone for participating in today's workshop. And hopefully, in the in coming days, we'll be having a very much jam-packed seminar. So can't wait to see you guys tomorrow as well. Thank you, sir. Thank you all.
Okay,
Thank you,
Siddharth,
Siddharth.
thank you.
The session is very nice, and it's going on the what way we thought to go. So
Okay,
tomorrow
thank
onwards
you.
it will be more interesting, I hope.
Sure.
Okay.
Thank you, man. Thanks for your comment.
Thank you.
Thank you, ma'am. And one more thing for participants, tomorrow session is by 4 o'clock. That is about 4 to 5.
Yes, sir. That will be a better, no?
Yes, ma'am. Yes, ma'am.
Okay.
That's what are planned, ma'am.
Yes. Okay, I understand. Thank
Okay,
you.
ma'am. Thank you, ma'am.
Bye.
All right. Thank you. Bye.
Thank you, Siddharth.